Andra, oh, there you are. Andra Lutu is coming up to speak about the BGP Visibility Scanner.
So how do I change this? No, this one. Okay. Hi, everybody. My name is Andra. I'm a PhD student at Institute IMDEA Networks and at University Carlos III of Madrid. I'm a newcomer. This is my first NANOG meeting, so please bear with me. Today I'm going to be talking about a cool tool that we have been developing. It's called the BGP Visibility Scanner. By we, I mean myself, my PhD advisor, Marcelo Bagnulo from University Carlos III of Madrid, and Olaf Manel from Loughborough University. Before I tell you how this tool can help you as network operators and what you can do with it and how cool it is, I'm going to talk about why we have thought about it in the first place. So, in very simple words, the internet is a network of networks, and the BGP is the glue that holds everything together. So, networks kind of exchange reachability information, they are able to define paths, and ultimately send traffic, which is the main point. But networks also want to achieve not only operational goals, but also economic and political goals. So BGP conveniently allows them to define routing policies and to define their preferences in traffic routing. But due to the fact that these are not publicly available and not everybody knows what each other is doing, only by configuring a routing policy you are never sure that you are achieving what you wanted to achieve. And also, we are only human, and mistake is human, so mistakes do happen, and you are never sure that you are doing the right thing. So we believe that operators need to not only monitor their own network and be very sure of what they're doing, but also they need an outside view. They need as many external views as possible. So that's what we are doing with our tool. We are providing network operators with an external view on their operations. We are focusing on prefix visibility as an expression of policy interaction, of stable policy interaction. And we are mostly defining today, like the most important concept we're going to be talking about today, and you're going to be hearing this a lot, is the limited visibility prefix. It's been proven that not all the prefixes make it to all the routing tables out there. And the limited visibility prefixes are exactly the subset of prefixes that are not present in all the full routing tables, or what you can understand of a full routing table, given that such a thing as a default free zone does not exist. Contrary-wise, we define also the high visibility prefixes, which kind of make it in all the routing tables we are looking at. So the tool, the BGP Visibility Scanner, what it does, it's to gather all the available BGP routing data from route views and from RIPE, from the RIS projects. And altogether, we look at about 24 collection points. In total, there are about 140 different monitors that give their full routing feed. And we look at the visibility of the prefixes in these full routing feeds. And what we present and make available is the set of limited visibility prefixes for each originating network. Now, the question we ask is this something that the operator intended? Is this something that the originating IS is suffering from? Is this something that somebody is inflicting upon this originating IS? So next I'm going to walk you through all the steps behind all the data manipulation. I'm going to show you the methodology to have it all clear and out in the open. I'm going to show you a few numbers based on a study case. So we're going to take like an actual sample, and I'm going to show you what we are doing with that particular sample. I'm going to show you a few interesting characteristics, or at least interesting for us, of the limited visibility prefixes. I'm going to show you the actual tool and how to use it, and how you can help me, and how you can help me by telling your stories if you find limited visibility prefixes that you are originating as a network. And also, this tool is kind of available 3 months now. So we have been able to talk with a few network operators, and we have a few use cases, and I'm going to present them to you, and I'm going to show you what happened there. So right, the BGP Visibility Scanner, just like any data analysis process, we have 3 main steps. We gather the data, we clean it, and then we process it to get what we want. First step, we gather the raw data from RIPE and raw views. We just randomly chosen 2 sampling times at 8 a.m. and at 4 p.m. every day. Of course, this can be changed. We can work with as many snapshots as we would like. Then we move on to searching in this raw data, the actual data that we are interested in and that we could further use for our processing. So we call this finding the global routing tables. Now, if you think about the raw data, there we have been able to identify 3 types of feeds. We have the partial feeds, so if you want to think about like customer to provider, peer-to-peer kind of relationships, this would be maybe a feed that a peer would provide to another peer. Then we have the full routing tables, or the global routing tables, or something that a routing feed that a provider would inject to a customer requesting a full routing feed. And the third type of routing feed is the global routing table plus like internal routes that are not really of interest for our analysis. So the first filter that we apply is the size filter, and we do not we discard every routing feed that has less than 400,000 prefixes. This is very straightforward. This is very simple. You just check how many routing feeds are in a kind of a global routing table. 400,000, okay, we discard everything. So we're left with full routing tables and full routing tables plus internal routes. Then, well, the monitors kind of sometimes give more than 1 routing feed to the collectors. And we checked what's inside that routing feed. We've seen that there are no differences. So we kind of discarded all the duplicates in order not to have false positives and so on. So at this point, we have our full routing tables, our global routing tables, and our global routing tables plus internal routes. We start looking inside the routing tables, and we discard their information that we do not want, like bogons, Martians, and information we cannot really process at this moment, like multiple originating prefixes. So just to give you a few numbers, if we take 24th of October last year, we were, in the raw data, we had like 500 different routing tables. We applied all the filters. We were left with 130 global routing tables. After eliminating the bogons, we discarded 500 prefixes out of the whole union, and the MOAs were about 4,500. So just to have a quick idea. Now, if we merge all the information from these 130 global routing tables together, and we check like the simple CDF of in how many routing tables do I see how many prefixes, so this would be the upper plot, you see there that on the x-axis you have the number of routing tables, and on the y-axis you have the probability of finding a number of prefixes in at least X routing tables. So you see a clear separation between the prefixes that are not making it to all the routing tables and the prefixes that are everywhere. And if we break this down by prefix length, so you kind of like see there the color code from cold, so not making it everywhere, to hot, red, making it everywhere. You see that this is not a problem that is characteristic only to, I don't know, prefix length longer than /24s, for example. You can see this problem kind of everywhere. So having decided that prefix visibility is something of interest, now the question is how many of these prefixes that do not make it everywhere, how many are there? So we're starting our actual processing step by putting labels to all the prefixes in the 2 sampling times. We put a limited visibility label and a high visibility label according to our previous definitions, right? So first, we look at in how many routing tables can we actually see a prefix. That's called the visibility degree. And after checking the visibility degree for all the prefixes, we discard the ones that are present in only 1 routing table with a nice path length of 1. So basically the ones for which we only have information that they are present in the originating IS. These we tag as internal routes and discard them. Then we move on to the actual labeling mechanism. It's very straightforward, it's very simple. We apply a 95% minimum visibility threshold. Whatever is below this threshold is labeled as limited visibility. Whatever is above this threshold it's labeled as high visibility. Very simple. At the end of this step, we're going to have all the prefixes tagged with at most 2 labels. Now the question is to remove the transient prefixes, the ones that are just converging, the ones that are not an expression of stable routing policies. And we do this by developing this labeling prevalence sieve. We're saying that a high visibility label is always prevalent. So if a prefix had made it at one point everywhere, then it's forever tagged as high visibility. And then we tag as limited visibility only the prefixes with 2 limited visibility labels, according to our 2 moments of sampling. So if we go back to our sampling case from the 23rd of October, we kind of see that we discarded 7,800 prefixes that were tagged as transit, so only had 1 label, and that label was limited visibility. So overall, we got about 500,000 prefixes. 20% of them had limited visibility, 80% of them had high visibility. So now the question is, are there reachability issues for these limited visibility prefixes? So what we did is look for each of the limited visibility prefixes, we looked for a covering high visibility prefix. And what we found is that there are some limited visibility prefixes that do not have any covering high visibility prefix. Those are marked dark prefixes, so are the black ones there. In our example, in like the sampling example, on the 23rd of October, we were able to identify about 2,400 of these prefixes. It's very interesting to actually find these prefixes because there may be prefixes that may have reachability issues in the lack of a default route. So now that we have defined our 3 main sets of prefixes, the limited visibility, the high visibility, and the dark prefixes, everybody can wake up now and pay attention to the characteristics of these prefixes. First one is the distribution on prefix length. We see that the high visibility, there are no more specific than /24 in the high visibility. This tells us that filtering or lack of filtering can be one explanation for why we have limited visibility prefixes. And that goes for the dark ones as well. Also, we check the IS path length, and we kind of see like here that the limited visibility prefixes are very much skewed to the left. So definitely they are not a random subset of the high visibility prefixes. This is a problem that is around the originating IS. The mode there for the distribution is 2, and that kind of like locates the problem. Now, it's very important to understand we're only sampling the networks that are active in those 2 projects. And it's very important to understand how the sampling affects the number of limited visibility prefixes we discover. And we see here just the distribution of prefixes on number of monitors that contain those prefixes within their routing tables. With yellow, you have the high visibility prefixes. With purple, the limited visibility prefixes. We kind of see that they are gathered towards the extreme parts of the plot. This means that as we add more monitors to our sampling process, then the chances are that we will discover even more limited visibility prefixes. If you want, this could be a measure of the complexity of the internet. It's a very simple and straightforward question. How many prefixes are out there in the internet? Also, it's very interesting here to note that the 95th minimum threshold that we imposed previously, it's not a stable value, so we could change it, we could shift it, but this is not very sensitive to that threshold, so 95% was just fine. Right, and then the question is, are these prefixes that we have tagged as limited visibility in one day, are there any changes from one day to the other? Do the prefixes just like magically change their labels, or do they stably stay like that? And the question is, yes, they stably stay like that, because we have done the one-day detection, which you can see with red lines and red dots, and then the 7-day detection, which means basically taking the set for each day and making the intersection over 7 days. And then you see on the y-axis in the upper plot, from 90,000 prefixes to 115,000, and the differences between the 7 days detection and the 1 day detection is just like 1,000 prefixes. So It's very, very small. And that goes again for the dark prefixes. The differences are very small. So indeed, this is a stable expression of routing policy. This is a stable expression of something going wrong. Now, the question is, is the originating IS aware of this problem? Is it something that it intended? It's something that it wanted? It's something that it's suffering from? Is it aware of the problem? So these are questions that I'm addressing to you, and I hope to get answers for those questions. And I'm going to show you how I can get answers from you. So the tool is, all this information is available online. The tool is a public tool. It's a web page. You can just go there. It's visibility.it.uc3m.es. So like go in your laptops and put this, go to the website. Put your IS number there. So for example, there you can fill your IS number. Then you get your prefixes. This is just an example. You can check in how many monitors your prefix is visible, in how many monitors the prefix is not visible. You can check if this is a high visibility prefix or a limited visibility prefix. And it's very important, I haven't mentioned this, the information is updated on a daily basis. So each day you're going to get new information. You can actually monitor and track how this changes every day. Now, there is a very short survey that if you have the time, please fill it. There are just 4 questions, 4 straightforward questions. Do not forget to hit submit. It will be very important for us to tell apart prefixes that are meant to have limited visibility from prefixes that are just a mistake, or to be able to know if you are aware of this problem, if this is actually a problem, and so on. So I was telling you that the tool is available now 3 months, since 3 months ago. And we have been able to talk a bit with a few network operators and hear their stories, as I hope that today I'm going to be able to hear your stories. One common explanation that we kept on hearing was that these prefixes are injecting only to peers. And that makes sense, because that immediately limits the scope, the visibility of that particular prefix. However, another example for intended scoped advertisements, we have found out about this when talking with the content provider who was geographically scoping, so on purpose scoping the announcement for a particular prefix. We came upon also some errors from a large ISP. He was very kind and explained to us what was going on there, and we helped remove about 6,000 of unwanted prefixes that were just getting away in the internet. So that was a very strong result. And also we have been talking a bit with a few root servers, and they were telling us about their problems that were kind of inflicted by third parties. So probably you are all aware of this, but I'm just going to go through this particular example. So these particular root servers were doing Anycast, and one problem that they encountered was the problem of no return path if at a peering side they did not have full transit from a peer. So that basically means that if a peer leaks the /24, for example, announcement here to another peer, then the root server cannot respond to the traffic that it gets from peer number 2 because it doesn't have any return path. So the solution they found for this was to tag locally the announcement of the /24 with no export. So peer number 1, when it was receiving the /24, it will no longer announce it to its peer number 2. So, but the problem was not quite solved because this leads to black holing due to no announcement. So these particular root servers were announcing the /24 with no export locally, but also from the base camp without any tricks, without any communities. So this means that, let's imagine that the peer from the previous example has a customer. The peer receives the /24 with no export locally and the /24 from the base camp. It marks as best route /24 with no export. Then this route cannot be exported to the customers. So the customers cannot reach the root server. Needless to say that should you have had this tool back in the day, then you would have been able to actually identify this problem. So the solution that the root server came up with is announcing the /23 from the base camp as a unicast, as a normal normal prefix, which acted as kind of a magnet for the traffic until the green peer, who was then able to route to the local root server, to the local anycast node. So this was just an interesting example. And the conclusion and the takeaway message I want to leave you with, it's this evolution of the number of limited visibility prefixes that we can observe here starting June last year. And, well, it's ending December last year, but the information is out there, so you can check it for today. We can see that since the BGP Visibility Scanner became operational and people actually started using it, even if the number of monitors we are using is increasing, the number of limited visibility prefixes is decreasing. So this is a very strong result for us. This is very encouraging. This shows that people are using it and people are finding it useful. I hope you will find it useful as well. I hope you will come and talk to me about your stories. If you find limited visibility prefixes, please do not shy away from sharing what's going on there. If you are aware of their existence, if you are not and you want to troubleshoot. If you want information that is not present on the web page, do not hesitate to contact me. I am available day and night. I'm a PhD student, so I do not sleep. Any questions, you can ask either me, either my advisor, or Olaf. There is also a paper we have just published now in the Global Internet Symposium at Infocom. Should you have questions that are not answered in today's presentation, feel free to read the paper or feel free to ask me. I think my interface is much friendlier than the web page interface. So, okay, if you have any questions, I'll be happy to answer. Thank you.
We do have one question from the video streaming chat. It's from Matt Petak at Yahoo. He asks, are you sure that dark prefixes aren't spammers doing fast flux announcements?
No, I mean, we haven't checked for that. That could be an explanation. We haven't checked for that.
Okay. Any other questions in the room?
Freddy Künstler from Init7. Brilliant talk. Thank you for sharing this. I have a suggestion. It's sometimes not only interesting whether the prefix is visible or not, but also how the prefix is seen. So how many AS passes are used for a certain prefix. So maybe if you want to go further in the studies, this could be interesting for some people.
Okay, thank you. Any other questions or suggestions? I'm open to suggestions as well. And to hear from you if you have found limited visibility prefixes.
Heather Schiller, Google Fiber. Can you, I don't see it on your website, it might be in the paper, but can you publish the full list of prefixes that you consider dark or limited visibility? I didn't see anywhere that you could break it out, and then you could sort of do the inverse and look at what prefixes you can't.
Right. Now you just put your IS number there, and you get either the list of limited visibility or nothing if there's nothing injected by that particular IS. But yeah, sure. I mean, I'd be happy to.
Right. But you could also look at it from the perspective of, I'm an AS. What set of prefixes am I not seeing that potentially other parts of the world are seeing?
Right.
So not just not which of your prefixes aren't getting out, what you're not getting in.
Right. Right. That's very interesting as well. We have been thinking about ways to develop our web page. Of course, feedback it's always welcome. This is like if you want like an alpha version. So it was just to raise a few exclamation points and to raise a few problems and to see what's your opinion on this. If you find this interesting, and so on. But yeah, thank you. Okay. So, any other questions?
Okay.
Okay.
Thank you.
Thank you. Thank you.